we have studied how to analyze a DC circuit with the help of mesh analysis. And the steps for AC mesh analysis is also the same as that for DC mesh analysis. See here, the difference is a DC circuit consists of DC voltage source or current source and resistances, while in the case of a AC circuit, it consists of AC voltage source or current source and impedances, which consists of resistance and inductance or resistance and capacitance, and in some cases a capacitance and inductance, and in some other cases resistance, inductance and capacitance. The next step is we have to identify the meshes and mark it as 1, 2, 3, etc. Here it is 1 and 2, see like this. In AC circuit also 1 and 2. Next we have to draw the mesh currents as I1, I2, etc. in clockwise direction. Next step is to mark the direction of currents. That is, at the point of entering we have to give positive sign, and while leaving we have to give negative sign. See here also current is in this direction, so at entering positive, leaving negative. In this loop current is flowing in this direction, so here positive, here negative. While in this loop current is entering here positive, negative, which was the same way we did in DC circuit analysis also. Then we have to write the mesh equations for each meshes, applying KVL and solve to get the currents. In this example, we are asked to find this current I, which is flowing through the impedance which consists of a resistance 8 ohm and inductance 12 ohm. Let this is impedance Z1, which consists of 6 ohm and inductance 8 ohm, while let this is impedance Z2 containing the resistance 10 ohm and capacitance minus J6 ohm, and let this be Z3, which is the impedance consisting 8 ohm and inductance 12 ohm. So here next we will mark the meshes. Let this is mesh 1, this is mesh 2. Then we will mark the mesh currents. This is mesh current I1, while this is mesh current I2. As per the direction of current, we will mark the current flow in the components. See here current is entering here, so we will be marking it as positive, and from impedance Z1 it is leaving from here, we will mark it as negative. In Z2 it is entering here positive and it is leaving here, so it is negative here. In this impedance Z3 it is entering here and leaving here. Here in this direction there is a rise in potential, while here it is fall in potential, positive to negative. This voltage given is 20 at an angle 0 degree, that is equal to 20 cos 0 plus j sin 0. We know that cos 0 is 1 while sin 0 is 0. This is equal to 20 volt, while here the voltage in polar form is 30 at an angle minus 90, which is equal to 30 cos minus 90 plus j sin minus 90. This is 0 while this is minus 1. So this becomes minus j30. Now for mesh 1, applying Kirchhoff's voltage law. For mesh 1, as per Kirchhoff's voltage law, algebraic sum of voltages is equal to 0. So here first we will take the voltage which is rise in voltage plus 20, then here positive to negative, that is fall in potential, that is minus I1 into Z1, then here also positive to negative, fall in potential, minus Z3 into, see in this case two currents are coming. I1 is in this direction while I2 is in the opposite direction. So the current flowing through this branch will be I1 minus I2. As we are in mesh 1, we have to take I1 first minus I2. This is equal to 0. Giving the values of Z1 and Z3, this is 20 minus 6 plus J8 into I1 minus Z3, that is 8 plus J12. 8 plus J12 into I1 minus I2 equal to 0. Expanding it, we will get 20 minus 6 plus J8 I1 minus 8 plus J12 I1 plus 8 plus J12 I2 is equal to 0. See here, I1 is here and here. We can add it together so that it becomes minus 6 plus 8, 14 plus J20 I1 plus 8 plus J12 I2 is equal to, we can bring this 20 to the right hand side, so it becomes minus 20. Let this is equation number 1. Then for mesh 2, as per Kirchhoff's voltage law, algebraic sum of EMFs and potential differences is equal to 0. For mesh 2, as per Kirchhoff's voltage law, we can write here, see fall in potential, so minus I2 into Z2. Here also it is fall in potential, so it is minus, what is this one? This is minus J30, minus J30 volt. Then here in this loop it is in this direction, so it is fall in potential minus Z3 into, as we are in loop 2, we have to write I2 first. I2, as I1 is in the opposite direction, minus I1 is equal to 0. This can be rewritten as, giving the values of impedances, minus Z2 is 10 minus J6, 10 minus J6 into I2, minus of minus plus, plus J30 minus Z3 is 8 plus J12 into I2 minus I1 is equal to 0. Expanding it, minus 10 minus J6 into I2 plus J30 minus 8 plus J12 into I2, 8 plus J12 into I2 minus into minus plus 8 plus J12 into I1 is equal to 0. Rewriting 8 plus J12 into I1, see I2 is here and here, combining together minus 10 plus 8, 18 minus J6 and plus J12 plus J6 into I2 is equal to, while we are bringing this J30 to right hand side, it becomes minus J30, and let it be equation number 2. Solving equations 1 and 2, we will get I1 is equal to 0.836 plus J 0.704 ampere, while I2 is equal to 0.673 plus J 2.313 ampere. Therefore, the current flowing through this impedance I is the difference between I1 and I2. I is equal to I1 minus I2, that is equal to 0.163 minus J 1.61 ampere. In this example, we are asked to find the value of V2 so that the current flowing this impedance 2 plus J3 ohm is 0. First of all, as we are doing for mesh analysis, we will mark the meshes 1, 2, 3, 1, 2 and 3. Then we will draw the mesh currents in clockwise direction. This is I1, I2 and this is I3. Next we have to do is to mark the polarities. See, current is in this direction. So in this impedance which contains the resistance only, it is entering here, so positive, leaving here negative. In this inductance, it is entering here positive, leaving here negative. In this impedance which consists of 2 ohm and 3 ohm in this mesh, it is entering here, we marked as positive, leaving from here, so it is negative. In this resistance, it is entering here positive, leaving here negative, while in this inductance, in this mesh, it is entering here, so positive is coming here and leaving point is this one, so negative is here. Then we will go to mesh 3. In this resistance, current is entering here and leaving here. In this resistance, in this mesh, current is entering here, so plus, and leaving from here, so it is minus. It is given that the current flowing through this impedance 2 plus j3 ohm is 0. See, we know that the current flowing this impedance is the same current which is flowing in this mesh, that is I2. I is equal to 0 means, that means I2 is equal to 0. So we can write I2 is equal to 0. Then for mesh 1, by Kirchhoff's voltage law, here in 30 volt rise in potential minus 2 plus, as the direction of current is in this way. So plus 30. See here fall in potential. So minus 5 into I1. Then in this inductance, two currents are there, I1 and I2. As there is fall in potential, minus J5 into, as we are in mesh 1, I1 minus I2, which is in the opposite direction. This is equal to 0. It is given that this current through this one, that is I2 is equal to 0. That is I2 is equal to 0. So the equation becomes this minus 5I1 minus J5 into I1 minus 0 is equal to, we can bring this 30 to the right hand side, so it becomes minus 30. Rewriting the equation, 5I1 plus J5I1 is equal to 30, or I1 is equal to 30 divided by this 5 plus J5, that is equal to 30 divided by 5 plus J5. As the imaginary term is in the denominator, to bring it to the numerator, we can multiply numerator and denominator by 5 minus J5, that is equal to 30 into 5 minus J5 divided by 5 plus J5 into 5 minus J5 is equal to 25 plus 25, that is 50. This 5 can be taken outside. 150 into 1 minus J divided by 50. Cancelling this, we will get here 3. 3 into 1 minus 3 into J. This is equal to 3 minus 3J. This is I1. Now applying KVL to this mesh 2, here it is fall in potential minus 2 plus J3 I2. Here also fall in potential minus 6 into I2 minus I3 minus, here also fall in potential minus J5 into, I2 has to write first, as we are in mesh 2, I2 minus I1 is equal to 0. So we already know that this I2 is equal to 0. This is 0. This is 0. This is 0. So this equation becomes, this term becomes 0. Here minus 6 into, this is 0 minus I3, that is plus 6I3 minus J into I2 is 0 minus J into minus I1, that is plus J5 into I1 is equal to 0. Substituting the value of I1, which is found as 3 minus 3J, here we can write as 6I3 plus J5 into 3 minus 3J is equal to 0, or 6I3 is equal to minus J5 into 3 minus 3J, that is minus 15J minus 15. Therefore, I3 is equal to minus 15 minus 15J divided by 6, that is equal to minus 2.5 minus 2.5J. Then for mesh 3, applying KVL, here current is entering plus, leaving minus, it is entering here, leaving here minus, while I2 is entering here, leaving here, it is minus. As this is voltage drop, minus for I3, this is fall in potential, so minus V2. Then here I3 is in this direction, positive to negative, fall in potential, minus 6 into, as we are in mesh 3, I3 has to be written first, I3 minus I2 is equal to 0. Therefore, minus 4I3 minus 6I3 plus 6I2 is equal to, we can bring this V2 to the right hand side, V2. This is 6I2 minus this I3 and I3 can be added, 10I3 is equal to V2. That is V2 is equal to, value of I2 we know that it is 0. So V2 is equal to minus 10 into I3 we have found as minus 2.5 minus 2.5J. which is equal to 25 plus 25j, which can be written as 35.36 angle 45 degrees in polar form. If you found any difficulty in understanding any terms used in this class, you can go through my previous classes, the links of which are given below. Thanks for watching. Please like it, share it and subscribe it by pressing that bell button so that you will be receiving all the notifications of my future videos also. See you next time. Bye.